So all of our wood fiber is oriented with the grain in this direction. So the tree is sort of growing up, and all of our structure in the wood runs in this direction. Has anybody split firewood before? So I understand, you know, if I were to take my axe and I bring it in this direction, so with the grain of the wood, that'll split really nice and easily. If I bring it this direction and I crack it with an axe, I'm just gonna make a big dent, right? So understanding how that sort of works. If I were to take this chisel and I'm going with the direction of the wood, I get this like very perfect cut that is the exact size and shape of that chisel. I can do the exact same operation with the exact same tool, but changing the orientation of where I'm working with the wood fiber. If we can understand that and why I get all this tear out and why the wood is not going to hang on in the same way, we're sort of 90% of the way there. So the wood not only is going to perform under tooling exactly in this way every single time, we've also got expansion and contraction in that direction as well, right? So if I'm looking at this billet, the direction that this wood is going to expand and contract, yeah, it's going to expand and contract here. So I can grow over a 6-inch piece of wood, I can grow 1/4 of an inch when it gets wet. That's massive. That's not a very big piece of wood. That's a huge amount of growth. Whereas in length, it's not going to grow at all. So really understanding that that's happening to us. Also understanding that, especially for the iron workers, where what you're picking up and putting down, you can kind of wrap it around with all of our rigging, you can put chain on it, you can bump it up against the ground, and it's okay for the most part. Wood will crush very easily. If wood crushes though, it's not necessarily the end of the world. We can actually bring it back. So the wood cells within the fiber, they look like little donuts. And so the interior of the donut's actually filled with water, and that's what keeps it in its shape. I can squish that donut, that wood cell, and I can actually force it back into shape. I can make it pop back. If I cut that donut in half, however, it's cut forever. So severing a fiber versus crushing a fiber are two different ways that we can sort of destroy the wood. One we can bring back, and what I'm gonna do is once we have all of our billets broken out, I'm gonna take a hammer to your project, I'm gonna put a big dent in everybody's project, and you're gonna walk it back, okay? So you're gonna save the wood, which is directly applicable, you know, if something gets dented or bumped or dropped or crushed under rigging, it's not necessarily a destroyed beam. You know, especially big 16-foot, huge beam, a little dent in it, we don't wanna toss it or bring the engineer in if we know, hey, that's a dent. I've crushed those wood cells versus severed them. I don't have to bring the engineer in. I can actually just bring an iron and a little bit of water in, and I can bring that back. Okay, so understanding the science behind wood fibers is really important before we start getting into any of the tooling, because then we can make some really smart decisions around our order of operation and how we're actually getting into cutting. So what's gonna happen as soon as the iron hits the water turns into steam. The steam can't go back through the metal, so it's going to be forced into the wood itself. And what's neat about this process is it's not a one-shot deal. So I can hit it with the iron and I can start to steam that out. Look at that already. So even where I've really destroyed it, it's starting to come back. And I can do this process 200, 300 times until it comes out. So something really little and goofy, but it can save you. Yeah, and helps you hopefully understand a little bit more of how wood fiber reacts with water. what's salvageable, what's not.